Since the dawn of astronomy, we've looked up at these oases of light and wondered
David Kipping.
if anyone else
What a legend.
inhabits the dark with us, whether we're on the precipice of joining some galactic of civilizations, or whether maybe, just maybe, this is it. We're alone.
You sleep, Finn. Hey, Brandon. Cool Worlds Lab. It's a real lab, by the way. That's pretty cool.
When I talk to the public about astronomy and this question of life elsewhere in the universe, the most commonly held viewpoint I encounter is surely it's impossible that we could be alone in the universe. After all, how could it be amongst this unimaginable number of opportunities?
Well, that means astronomy and astrophysics and the science popularizers have done well, right? Because that was never the case in history. If you ask people going way back for most of human history, they would have said the exact opposite. So I think we've done well to get the word out there.
Opportunities for life to get going, it only happened once, only here. And this is a viewpoint held by many scientists and talking heads in popular media too.
Do you think that there is
Hey,
life
it's my boy.
outside of Earth, intelligent life in the universe?
I might be
Absolutely,
too loud.
there is life elsewhere, and almost certainly intelligent life. It has to be.
Test.
The odds are just overwhelming. There's 200 billion stars in this galaxy. Well, now it looks like every star has about 10 planets, so there's almost certainly intelligent life.
I assume it's the most frequently asked question, are we alone?
My best guess is that the universe is teeming with life.
There's surely other civilizations out there in the universe. There are 350 billion galaxies out there in the universe.
But an argument based solely on statistical grounds comes with a fatal flaw, and that is that it is perfectly plausible that the probability of life starting from scratch, which we call abiogenesis, is a number which is so small that it greatly outweighs the number of opportunities, the number of worlds out there in the universe for life to get going. For example, if the probability of life beginning is 1 in septillion, say, then the case for a crowded universe evaporates. In such a scenario, we were the only example of a success. And so we are simply unaware of just how unique, how special we truly are. Our anthropocentric bias clouds our view. This is precisely the point.
So I want to weigh in, but at the same time, my nature is to kind of listen to everything and then talk about it. So whilst doing these YouTube videos, I really have to go against myself and like talk at bits, because otherwise I know it gets boring. I mean, the video is amazing, but I know you guys are watching to hear what I think, right? So I would say in that little bit, I agree with everything. The only thing is that I could add, well, there's a lot, but the abiogenesis, right? We don't know what that even is. We have not much knowledge about it, and we don't know how much time it takes for some life to just sort of spontaneously form, given the right circumstances. So there's very little we can say about it, and I'm curious as to how much he's going to say about it. Not really, because he's replying to Elon Musk, who said life is probably everywhere.
Point made by friend of the channel, Professor Sean Carroll, when he
Elon's not a friend of the channel? I'm sure Elon's a friend of the channel. We literally read this in yesterday's video.
Elon Musk's more widely held view that life must be common. Let us make no mistake, though, the vast numbers of stars, the discovery that planets are common, and that even potentially Earth-like planets are common, all of these points move the dial closer towards a crowded universe scenario. But critically, without knowing the probability of abiogenesis,
we're going to go balls deep, Walter. So you better strap in, mate.
We may simply be moving that dial from, say, 1 in octillion to 1 in septillion. And so crucially, the statistical argument can only really be made if we have 2 pieces of information in hand. We need both in order to complete our understanding. The number of habitable worlds out there, or potential seats for life more generally, and also the probability of life spontaneously emerging on those worlds. Astronomy has clearly made great inroads about one of these two pieces of information, but what does science tell us about the other? What is then the probability of life spontaneously beginning, the probability of abiogenesis?
It's an exciting thing to think about. I have some controversial opinions on this.
Assessing the probability of abiogenesis has proven to be incredibly elusive and challenging for modern science. Rather than speculating about this, let's focus here on what we know and come at the problem from an observational perspective. Let's start with the fact that all life on Earth uses water to survive and is carbon-based. Two chemical ingredients which we certainly know to be common in the universe. What's more is that organic molecules such as benzene, urea, sugars, and even amino acids appear to naturally form even beyond the Earth, such as on interstellar dust grains, comets, and molecular clouds. So certainly the chemical ingredients which go into Earth-based life are found frequently across the cosmos. But that fact alone doesn't establish that life must be common in the universe, because it doesn't.
Might have a little disagreement here. I think it actually just might. Think. And it is kind of an argument on statistical grounds again. But if you bring everything together that life needs, life actually might be fairly inevitable. And I'm sure eventually we might come up with some mathematical proofs. I think this is also a thing for the theory of computation. You know, have you guys ever heard of cellular automata? You put a few rules, from a few rules you get complexity, and you simulate these 3 rules and you iterate, and it leads to immense complexity that is beyond our wildest imagination from these really 3 simple rules. And the universe is way more complex than 3 simple rules, at least it looks. It might only be a few simple rules. And so with all this complexity, it's really hard to imagine that more complexity won't form in pockets. And, you know, you've also got to sort of invoke, you know, entropy and talk about that into this argument as well. But I just think if you bring together all this stuff, it's actually might be inevitable that this stuff forms life.
Doesn't say anything about the probability of those chemicals coming together in just the right way to create a self-replicating chemical network capable of Darwinian evolution, a possible working definition for life. At a basic level, we certainly know that no lab experiment here on Earth has ever succeeded in creating what we would call life from.
But we've also got to consider that we haven't been trying for very long. You know, we really haven't. And when we're invoking statistical solutions, you know, we're thinking about cosmic times. So to say that we've tried very hard would be a mistake. And not only that, I suspect one of the problems, one of the reasons we can't kind of do this abiogenesis is there's probably some mechanisms we're missing, you know, that are equally as important to natural as natural selection. And just Darwinian evolution. There's just so much about the human body we clearly don't know still. Clearly. And the mind of consciousness. You might have seen AI recently solve the protein folding. And it revealed a lot that was right in front of our noses that we didn't even realize. Like, you know, the way they're folded actually codes for things. We didn't know that. There's like more folding than we thought. And so it's all right in front of us probably, and we're just hairless monkeys trying to like stick sticks together to reach a banana in the tree, and like Richard Feynman said, right?
The fact that we have not succeeded in creating life from scratch from these chemical broths, despite many attempts, demonstrates that at the very minimum, life is not an inevitable or even particular.
I completely disagree there. We have not tried for long enough to say that. I can't believe he made that reach, saying, you know, life at this point we can say is not inevitable. We can't say that. I mean, just think about this. The exact opposite is true. Here we are in a universe. The universe exists, it seems like. But let's assume that's true. We exist. So life is thus inevitable, isn't it? Because we exist in the universe. Do you see what I'm saying? So it's therefore inevitable, but he's just said the exact opposite.
Particularly likely outcome of just stuffing organic molecules together and waiting for a few days. These experiments may be flawed or simply...
That's assuming that we started by natural means. Of course, it could be some funny business, like some kind of Prometheus, what do we call it? Artificial panspermia, where like life is like seeded on worlds. Maybe we were seeded.
Not run for long enough yet, but it's also compatible with the hypothesis that the Earth really was exceptionally special. It had just the right conditions, or perhaps was extremely fortuitous that a specific set of chemical reactions occurred in the necessary sequence at the necessary times. And these ideas start to broach onto the famous rare earth hypothesis first posited by Ward and Brownlee in 2000. A common counterargument to this is that the proliferation of life on Earth across a very diverse range of environments surely implies that life is capable of surviving, indeed, in a broad array of conditions. In particular, life forms known as extremophiles, like the tardigrade, for example, are able to survive in acid baths, boiling water, or even the vacuum of space. Surely this means that life would be easy. And indeed, this was precisely the line of argument Elon Musk threw back at Professor Carroll in their Twitter exchange. Now, whilst I agree with what Sean wrote in response to Elon, I think a more pressing concern with Elon's line of argument is that extremophiles are highly sophisticated organisms with advanced complex internal machinery to help them cope with these diverse range of conditions in which they inhabit. They are the product of billions of years of evolution. But the very first biological cell to emerge from muck could not have been equipped with this kind of advanced internal machinery. It would have been far simpler. And so the fact that life can adapt to extreme conditions does not speak to the question as to whether life can start in extreme conditions.
I don't know if that's true. I don't think that makes any sense either. I think that's a reach that isn't quite logical. And not only that, I think if you look at Earth's history, we now have evidence that life arose very quickly. We think Earth is about 4.6 billion years old. We can date rocks to then. And we now have pieces of evidence to show that life might be as old as 4.1 billion years. And so you might be like, well, that's 500 million years. Well, Earth for that first little period should have been extremely inhospitable to life. Inhabitable. It shouldn't be possible for life to exist. Even at 4.1 billion years, we're confused. And so it almost seems like as soon as life was possible, it emerged. Now, I think that says something. And I think that says the exact opposite of what he just posited. So I think we might find wherever life is possible, this is my opinion, wherever life is possible, it'll pop into existence. Much like, I think this will be very analogous to just quantum fields and how they work. Because what are we but, large scale, macro, emergent stuff from quantum fields. And with quantum fields, when you seemingly have nothing, stuff still pops in and out of existence randomly. And I think this will just be like life. I think it's also connected. I'm speaking about it very philosophically and loosely, but when you have no data, what else can you do? So I think it's going to be very analogous to just the bubbling quantum foam. And I think life will be everywhere.
Leaving extremophiles aside,
also, we got to say, he's coming at this from just an extreme scientific point of view where he's giving you all the uncertainties and he's saying, but what about this and this? Just the science. He's not really sharing his opinion. I am right now sharing opinions. Okay, so I don't think it's fair to say he's being pessimistic. I don't actually hear many opinions by him. He's actually just giving you the science, which is great. And I think that's a really good thing to do. I am just giving mostly opinions. So it's not fair.
Common argument I encounter in favor of a crowded universe scenario is that life appears to have begun quickly here on the Earth. And on the face of it, that appears like a good argument. Microfossil evidence and hypothesized biologically manufactured mineral deposits indeed indicate that life was active on the Earth soon after conditions became suitable for life, perhaps just a couple of 100 million years after the Earth's magma surface solidified. Surely,
It's even less now. It's 2019. Looks like it may be even 100 million years or less.
the early emergence of life on Earth demonstrates that life is a relatively easy process to get going, and thus we should expect a universe teeming with life, right? Actually, no. And this is a misinterpretation of that fact, which is very common even amongst scientists. This is really a question of statistics. And to understand where this flaw in the logic comes from, let's go through a thought experiment together. Let's imagine that I take 1 million people and I lock each of them inside a prison cell, 1 cell per person. Now, each person doesn't know about the others. From their perspective, they might be alone or they might be one of many. Each person is given 1 minute to pick the lock, else the occupant will be killed. And to be kind, let's give each person a hairpin to try and pick the lock and get out. So the timer starts and everyone starts trying to get out. But they have no idea how hard the lock really is. In fact, the lock can be picked, but it takes, on average, about 100 hours of random prodding before it will click open. Now, after the timer ends, as you can imagine, pretty much everyone is dead. Okay, I admit this is a pretty horrendously unethical experiment, but bear with me. Now, remarkably, not everyone died. 1 person did escape. Let's call him John. Now remember, John actually has no idea how many people were locked
John 117. And his name is.
up and just tragically died. So imagine now walking up to John afterwards and saying, "Hey, you picked the lock. Was it hard?" He'd say, "Oh, no way, it was easy. I actually picked it first time. I got through it in 5 seconds." From John's perspective, he only has 1 data point to work with, and that's himself. And from his perspective, it was a piece of cake to get through that lock. Now, if John were to learn of the other 900
But if he knew a little math and he looked at the lock and he was like,
Hey, wow, I can't believe I just did this first shot. That should have taken me 100 hours. Now let me consider if there was a bunch of other humans. Wow, I could be the only...
do you see what I mean? It doesn't make any sense. Just look at the history of science and astronomy. How many times were we arrogant enough to speculate that we might be the only sun, we might have the only sun, we might be the center of the universe, we might be the only planet, we might be the only... At every point, we have been knocked down and taken off our little pedestal. Why are we still making this mistake? I'm not saying we need to just 100% think there's life, but if history stands for anything, it's telling us to not be arrogant in our speculations. No? And I'm not going to stand on that side of history again.
99,999 dead cohabitants, he would surely
With the
reevaluate
Vibius.
his position and realize that the lock is actually incredibly tough to break. But because he only knows of the winners, which is to say himself, then his only data point is telling him that the lock is easy. And of course, in the
I gave you how you could actually work out that's not the case. I'll say it again. You could just look at the log, look at how long on average it might take, run some simulations, work out, all right, well, maybe if life is common, there would be 1 every so often. And that's what we try and do with life. That's literally what we're trying to work out. But what we're trying to work out right now is that lock and how long it would take for it to just sort of, you be able to randomly do it. We're trying to work out how long abiogenesis takes just randomly given the right circumstances. And we can't figure that out yet. And so we can't actually basically statistically infer how many other, versions of John there might be. That's the simple argument. So all we really can do is use common sense, the history of science, to sort of infer and extrapolate and guess.
Same way, let's now imagine that each prison cell is a planet, and each trapped prisoner is representing a chemical soup, if you will, trying to become alive in the limited time available whilst the planet is habitable. Well, we are John. Earth is the one that got through the lock, and from our perspective, it seemed quite easy because we got through it pretty fast. But what about everybody else? Well, we have no idea.
Also, keep in mind, like everything I'm saying, right, I'm not confident in. There's huge uncertainties. So it might sound like I'm saying, oh, there's definitely life everywhere. I'm going to say 60% confident life is everywhere and just like us. But really, the uncertainty there is huge, and I don't know. So please don't take it the wrong way.
Maybe the lock is easy, and there are countless inhabited worlds out there just waiting for us to find. Or maybe
Oh, thank you.
we are
Copagnetic.
completely alone. No one else picks the lock. So clearly, we are missing a huge piece of information necessary to figure out the true answer.
All we need to figure out to figure this answer out is actually something else, one thing. We need to determine if the universe is truly infinite in nature, which might be impossible for us to do. But if we could work that out, we would have our answer to this. We really would. So, if we want to answer if there is other alien life out there, we should focus on determining the geometric shape of our universe, because if it's flat and open, it might be infinite. But there's a problem there. It's really hard to do that. And, the universe might be so big, so much bigger than the observable region, that it just appears flat in our little region. And kind of like if you had a circle, so like a spherical, but like imagine 2D circle. If you zoom in on the edge enough, eventually it'll be a straight line. And this could be analogous to the universe. We might be in this region that appears flat and, open and infinite, but really, you zoomed out somehow, you'd see that it is closed.
The fact that we picked the lock quickly doesn't actually matter, because we may very well be a statistical outlier. In a scenario where the probability of abiogenesis is hard, then the time it takes for life to get going on planets where it does get going tends towards a uniform distribution. So in our prisoner analogy, repeating the experiment many times and asking all the survivors how long it took, you would find that their times would be uniformly distributed from nearly instantly up to the maximum time, 1 minute. This mathematical result was first pointed out by the economist Robin Hanson in 1998, and it's easy to prove analytically too, as was done so in our own paper on the subject recently, which I'm linking down below in the description. So if life is hard to get going, then because of this uniform tendency, an early start to life is just as likely as a late start to life. In fact, if you think about it, a late start to life is actually kind of prohibited, because if life had started on the Earth late, then there would have not yet been enough time for bipedal hominids such as ourselves to have evolved and start to ponder these kinds of deep questions. And thus, the fact that life started quickly here on Earth actually provides essentially no information about the probability of life being present elsewhere. Statistics flatly disagrees with our naive intuition. I think it's
But again, you don't need to use statistics there. You just need to use common sense.
difficult
And as soon as
to characterize.
it's funny, because as soon as we have one other sample point, this whole notion goes out the door. That will give us enough. It's not great having a sample size of 2, but it'll give us enough to then actually throw this argument in the bin and do some statistics. And so what we're trying to do, right? We're trying to find if life has actually arisen elsewhere in our little solar system. Because if life has like arose separately twice in one little solar system, that's going to say a lot. It's going to say a hell of a lot. Anywho, that was an amazing video.